Hello guys, and welcome to another video with Cass on the Mizuno channel. So today we're going to take a look at some solutions for the animated esports sign. I have a bunch of them that are interesting to see, so let's start by checking out the first simple solution as well as the puzzle itself. So this is the board and it just has 5 different outputs. So there's this pair here, the clicks, and the drink thing is in here. So they're here to help us control this animated display that you can see on the right side of your screen. And as you can see here, if we play the animation, you can see that the lady here will click the mouse button for the first frames, and then we need to activate the other frame so that she will pick up a glass, drink from it for 2 cycles, and then yeah, pull it off her mouth. that sounded bad, I don't know. And then yeah, stores the glass once again, and then the animation keeps repeating. So my first solution was to use 2 MC4000s for this, as well as the MUX here, the DX300. And I work at the solution by looking at the output. So data analysis is a great tool to do in here because those are actually all outputs, those are not inputs, so this is fine. And here you can see that the click 0 and click 1 are basically the same thing. They're just a wave pattern, but they are inverted. When one is high, the other one is low. So this is what I do here. I just move the value of the accumulator to one of the pins, and then I invert the accumulator and move the results to the other pin, and then I sleep and I keep doing this, and this will generate this simple pattern that you see up there. For the drink, it's a little bit more complicated. As you can see here, the waveforms are a little bit more complex, but it's possible to control them if you use simple move instructions. So as you can see here, I start by moving 0, 0, 1 to this guy, which means P0 activates, and then those two become 0, right? And this stays like so for 6 cycles. And if you look at the waveforms again, this is exactly what it does. So active for 6 cycles, and then deactive, or 0, better said, 0 for 6 cycles, and then I have to do something. But this is basically what I do. This component is really great because it allows you to when you move a value to it, it will allow you to activate certain lines and deactivate other lines all at the same time, so you don't have to use 2 instructions for this. So this is a very simple solution. And let's see, as a reference, this costs a total of 7 and uses 218 power and 12 lines of code. The next interesting solution is this one using AMC 6000. So costs the same as the basic solution, but uses a lot less power and 1 line of code less. Okay, so look at this new layout. As you can see here, it takes advantage of the fact, as I mentioned before, because of data analysis, we can see that whatever happens to click 0, you have to do the opposite on click 1. So this is why I use a NOT gate here. This way I can control 2 outputs using only 1 gate, which is awesome. And as you can see here, this solution uses a single microcontroller. I don't need 2 for the same job. And then here I just have the MUX. And here the code, the code is interesting. I use the gen instruction, but if you remove all the things, all the details, meaning those things that I move, the values that I move to the MUX, you can see that the solution is basically a bunch of gens. Look at this, guys. So I'm basically trying to control the click 0 and click 1 all the time. So for instance, this instruction will take 2 cycles, and this one 2 cycles, and then those 3 together will make a total of 6 cycles, which is exactly the time that we'll have to wait here if you look at the wave pattern down here. And then from that point on, I need to do instructions that are slightly more complicated, so slightly more elaborated, I could say so, because this one takes only 1 cycle, 1 cycle, 1 cycle, and 1 cycle. I have basically to break down this thing that goes high for a cycle and low for another cycle, and break those into different components so that I can change the other signals that go to drink 0, drink 1, and drink 2. So let me restore the code in here. So yeah, that's it. So I keep doing the gen thing for the clicks, and then I have to move just a few values to the DX300 in order to do the other stuff. So this is a pretty simple and very nice solution. The next interesting solution is a ROM-based solution. So same cost as before, but uses a lot more power, but just 7 lines of code, guys. Well, let's check this out. So yeah, this is a ROM-based solution. So let's take a look at the layout in here. So as always, we're using our DX300 here to power the 3 lines in there. I use the same trick in here, so I still just need to power this guy and it will control both outputs in there. But what about the code? I don't need a lot of code now because I am using a ROM, as you can see in here. So I pre-programmed all of the things that I want to do. So maybe it would be good to look at the waveforms for now. So let's hit the verification tab and let's see what it does. So basically this guy, he copies a value from X0. X0 is connected directly to the ROM. So if you, in case you don't know how this works, a ROM has two different connections, one for data and another one for address. So basically you can select one address inside, which is going to be one of these slots, and then you can read the value inside it through the data bus, right? And the second thing you need to know about those chips is that every time you read from data, it automatically updates the address, so it increments it by 1. So if it's currently reading from here, once I do this, move X0 to the accumulator, reading from data, so it will move the address to this, and next time it will move this. So basically, only using a move instruction, you can read the entire memory. So yeah, and I had to use a bunch of tricks in here because, as you can see, I only have one connection in here to the ROM. And the problem is our pattern goes extends for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cycles or 10 time units, right? So after that, the pattern starts repeating. So I have to do something different every cycle, but there are 10 cycles until we repeat again. But the memory chip has a total of 14 slots, and 10 is not a multiple of 14. So yeah, here we have a little problem that we have to take into account. If we could connect to the address line somehow, if we had a port to do that, then we would be able to control the address. So whenever we read 10 values from the memory, we could just reset and read 10 more values again and again. But we only have one connection. I hope you guys understand what the problem is in here. So what I do is I read a value from the memory, and if it's 0, I skip, and otherwise I just output it. So the value that I read is the value that goes to those 3 guys in there. So as you can see here, the first value is a 1, which means that this guy is going to activate first, drink 0. And if you look at the wave patterns down here, yeah, drink 0 is the first one to get activated. And next cycle, it's still going to be activated. You will see that I also have different values, so different signs in here. So there's negative values and positive values. And you have to know a little bit, this is a little bit tricky, but the DX300 can read negative values. It only cares about the values in each digit. It doesn't care about the sign. So a 1 is the same thing as a -1 to this guy here, to the DX300. So it will keep outputting 1 for 6 cycles, as you can see here, and then it outputs 1, 0. So it will turn off this P0 in here and will turn on the line in the middle, because that is what happens in here. As you can see, drink 1 gets activated at that cycle. All right. So basically, I'm reading the ROM and outputting the different values in here. And the reason why I have positive and negative values is because I need to find a way to control the click 0 and click 1 lines. So what I do here is, if the value that I just read for the DX300 for one of those guys is a positive value, then I activate P0, I make it high for 1 second, and well, I turn this on, so this goes on and this goes off. And if it's a negative value, then I activate, instead I make it low for 1 cycle. Yeah, a little bit strange, but this is how I get to control everything. And to make it clear, what I do when I reach this point where everything is 0 is I keep looping, because check this out. If it finds a 0, it jumps back to SKP or skip, and it keeps skipping as long as it sees 0. So skip, 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 and then it gets to this point where it won't skip anymore. And the trick is we don't sleep in here. You know, we keep reading those real quick until we find a valid value, and then we go back to doing whatever we have to do so we can sleep in every cycle. And we sleep by using the gen instruction. We also take advantage of that. Here is a slightly improved version of what you just saw. It uses the same mechanism, but as you can see, the cost is down to 6 now, and it uses a little bit less power and the same amount of lines of code. So let's take a look at that. So the cost is lower because I got rid of the not gate. All right, the ROM is exactly the same. The code still does this. So if it finds the 0, it skips this entire section. And the thing that I do different in here is instead of moving all the values to here, when it's time to power this guy, or when it's a positive, I power P0, which is this guy here, and when it's negative, I power P1 on this side in here. So yeah, made it a little bit cheaper. And finally, to the last improvement on the super low cost version of the solution. Same cost, so 6, but it uses less power. And I call this one the skipper. So this one is the looper because it skips values by looping. And this one is called the skipper because it doesn't need a loop. So the code the code still uses 7 lines, which is really cool. This is the layout, so quite simple. I can press tab if you're feeling confused about this. So look what I do here. The ROM is modified now, as you can see. And as you can see also, we don't have any labels in here, so we don't loop. What we do instead is I organized the ROM in such a way that if you find a 0, it is invalid still. But one thing we know for sure is that if it is an invalid value or 0, the next value is going to be valid for sure. So we don't have to skip 3, 4, or whatever number of values. We just go to the next value. So check the code. We read, so we pull the value from D0 into the accumulator. And if it's 0, all we do is we pull another value in, and that's all, because we know that the next value is going to be valid. So we do all that we have to do. We move this value to x1, which is the output to the DX300, and then we do the same thing for the clock 0 and clock 1. And yeah, so this is more power efficient doing it this way. And finally, I just want to show you guys one more solution because this is a trick that is very, very much important to learn. It's a little bit advanced, but it's very important to learn in this game. So I'm calling this the unstable layout. So same number of lines of code, still ROM based, low cost, but it uses a lot of power. Yeah, maybe you guys will be curious to know what this is. So the weird layout thing that I'm talking about is this. So starting from the basics, we still have a simple I/O connection to click 0 and click 1, so that is fine. DX300 is doing its thing, but look at this, this shape in here. So the weird thing in here is that we are connecting X0 to the ROM, to the data port here, and we are also connecting it to the DX300. So when we read, are we reading the ROM or are we reading the DX300? I don't know. And when we are writing, do we write to the ROM or do we write to the DX300? So the last question is a lot easier to answer because this is read-only memory. You cannot write to it. It's not RAM, it's ROM. So when you write to X0, it always writes to the DX300, so we are safe on this side, right? We'll never write to this. It will always ignore it. But when we read X0, for some reason, it always reads from the ROM, so we're always fine. You see the pointers moving in there. And I don't know, this wasn't supposed to work. I can run the entire simulation for you guys if you want to see. This wasn't supposed to know because as I read in the specifications, if you have a bus, especially X bus, connected to 2 different devices, and you try to read from it, the game will randomize the input. So sometimes we will read from the ROM, and sometimes we should be reading from the DX300. But for some reason, This layout works all the time. In the past, the game used to have a deterministic order, so if you have connections, so ambiguous connections like this, the game would always read whatever component was placed higher, like this, because probably the entire circuit was interpreted as a matrix, so it reads from top to bottom, something like this. But this changed, so this changed into the behavior that I described it to you. I cannot undo what I just did. Okay, so it just changes to the behavior that I just described. So it should randomize. So sometimes I should read from this, sometimes I should read from this, which makes your code inconsistent, but it doesn't. As I just showed to you guys, it still works. And for some reason, it also uses a lot more power. Maybe X0 is actually actively trying to pull data from here and here at the same time, so twice as much power driven drawn. I don't know, those are just theories, but having one thing connecting to two things at the same time is a very nice trick to learn in this game, which is what I wanted to share with you guys. And with that said, I also can't wait to share with you guys my next solutions to the next puzzles. So thank you very much for watching. Feedback is always very much appreciated. Thank you very much for watching again, and goodbye.